Hey, what's up? This is Mr. Love here. As I promised, I'd put today's quiz up on the solutions for the test tomorrow, so you can check them out and study from them. Number one, what is the direction of force that acts on a clothes in the spin cycle of a washing machine? We learned that there's a force that acts on all things, all rotating systems, and an acceleration. It's called centripetal acceleration, centripetal force. That force is always directed to the inside of the circle. That's a pretty poor circle. So the answer to this is A, inward. Number two, a tin can whirled at the end of a string moves in a circle because the same thing that's going on in number one. The can does not actually pull on the string. That's centrifugal force, which is an imaginary force. That's its natural tendency. Number two, this doesn't work out. There's a force on the can pulling it outward. That's the same as A. Again, that's wrong. And D, there was an inward force acting on the can, the same as centripetal acceleration, centripetal force. So the answer to this one is D. Let's see. Number three, as the rotational speed of a space habitat increases, the weight of the people inside, and this is as a result of centrifugal force, actually. If you have a circle and there's some object inside that, in this circular reference frame, it appears to the objects that are moving around that there is some force that pulls it to the outside. We know that this acceleration in the force is tied to the velocity. So if we're looking at force, there's a formula that relates velocity to the amount of force, v squared over radius. So as velocity increases, the force increases as well. So the answer to this is B. How much work is done to lift a 20 Newton crate that you move 2 meters? Simple work. Force equals work times distance. So force is equal to, have this backwards. Work is equal to force times distance. Sorry about that. So work is equal to the force, which is 20 newtons, times the distance, which is 2 meters. That work equals 40 Newton meters or 40 joules. The answer is E. Okay, number five, how much power is expended if you lift a 60 Newton crate 10 meters in 1 second? Power is force times distance over time. So power is equal to 60 newtons, which is the force. The distance is 10 meters. And the time is 1 second. So this just ends up being 60 times 10, which equals 600 joules per second, or 600 watts. The answer is E. Okay, moving on. Question number 6. It takes 80 joules of work to push a large box 8 meters across the floor, the same direction as the move. What is the magnitude? So it's just asking the value of the force. Again, work equals force times distance. So the trick to this problem is this 80 joules here is the work variable. Okay, so 80 joules equals the force, which is what we're solving for, times the distance, which is 8 meters. So in order to get the force, you simply divide 80 joules by the 8 meters. The force is equal to 10 newtons. Okay, that's answer B. Okay, and this last problem, ladybugs in the inside of a spinning bicycle tire can experience a force that feels like gravity to them. This goes back to the question above here, where it asks about the rotational speed of a space habitat. For the frame of reference of the ladybugs, all they feel is the centrifugal force, or the force that's pulling them to the outside, and to them that actually feels like gravity. Okay, so you can check your notes for that, but the answer to this is true. So this is part 1 of 2. I'll do another video in a minute that'll have the second part of the circular motion stuff. Okay, so stick around for part 2.